Hi grade 10s. Today we're going to be simplifying radicals. Radicals are very similar to fractions. We can simplify them so that they're easier to work with, and to simplify them we take entire radicals like the square root of 75 and to mixed radicals like 5 square root 3. Not all entire radicals can be simplified. That's also something that's like fractions. Some fractions can't be simplified. Some fractions can be. So here we are. We're going to simplify the square root of 32. So to simplify a radical, what we have to do is we have to think of two numbers that multiply to 32. Here's the catch. One of those numbers has to be a perfect square. In other words, a number that you can take the square root of. So if I'm thinking of two numbers that multiply to 32, where one's a perfect square, I'm thinking 2 and 16. So 2 and 16. 2 times 16 is 32. So now what that means is that the square root of 32 is going to equal the square root of 2 times the square root of 16. Now the perfect square here is 16. It's not 2. The square root of 16 is 4. So this becomes 4. The square root of 2 is still the square root of 2. So it's 4 square root 2. That's how we simplify the square root of 32. Okay? Now, let's take a look at b, the square root of 80 divided by the square root of 10. When we go ahead and do this, what we need to do is divide those numbers. So we divide what's inside the root. 80 divided by 10 is 8, so we get the square root of 8. And again, we're looking for two numbers that multiply to 8, where one of them is a perfect square. The only two numbers that multiply to 8 besides 1 and 8 are 2 and 4. So if we look at 2 and 4, 2 is not a perfect square, but 4 is. So it's the square root of 2 times the square root of 4. Square root of 4 is 2, so it's 2 times the root of 2. So the square root of 8 can be reduced to 2 root 2. And finally, we take a look at square root of 5/4. If we have a root over top and bottom, what that means is we can look at the root of the top divided by the root of the bottom. So root of 5 is the root of 5. We can't do anything to change that. But the root of 4 is a perfect square. The square root of 4 is just 2. So this actually reduces nicely to the square root of 5 over 2. What if we want to work backwards? What if we want to take something like 4 root 3 and write it as an entire radical? In other words, like in this last question, we had 4 root 2. We want to take that and turn it back into this. How do we do that? Well, what we need to do is we need to take a look at the whole number. Here, 4 is that whole number. 4 is equivalent to the square root of what number? So we have to think about this. What's the square root of what number is 4? To figure it out, we could just take 4 and square it. 4 squared is 16. So 16. And then we've got that root 3. So now all we have to do, oopsies, that should be a 3, not a 13. Not sure where I got 13 from. 16 times 3 is 48. So this becomes the square root of 48. So working backwards and writing 4 root 3 as an entire radical, we get the square root of 48. Next example asks us to arrange the following in order from lowest to highest. To do this, what we need to do is write these all as entire radicals. So the shortcut could be 3 times 3, or 3 squared is 9, times 2 is the root of 18. So if we write this as an entire radical, it's going to be the root of 18. The second one, 2 times 2 is 4, times 5 is 20. This will be the root of 20. 2 times 2 is 4, times 6 is 24, so that's going to be the root of 24. And the fourth one is already an entire radical. So if we're writing these from lowest to highest, which one's the lowest? Clearly the root of 18 is. But we don't write root of 18, we write the original number, which is 3 root 2. So 3 root 2 is the first one. Okay, so we got 3 root 2. What one's next? The root of 19 is the next one, so we write out that one. So that one's gone. It's toast. Then we get the root of 20, which is 2 root 5. So that one's the next lowest. And by process of elimination, 2 root 6 is the last one. So that's how we write those numbers in order from lowest to highest. So we write them all as entire radicals and then rearrange them. Okay, a few more examples here. If we have 4 root 3 times root 16, what do? We multiply numbers outside the root by numbers outside the root, numbers inside the root by numbers inside the root. So there's no number here, so we'll assume there to be a 1. 4 times 1 is 4. 3 times 6 is 18. So we get 4 times the square root of 18. Then we have to ask ourselves, what two numbers multiply to 18 where one's a perfect square? Well, it's going to be 9 and 2. So the square root of 9 is 3. Square root of 2 is a square root of 2. So we get 4 times 3 is 12 root 2. So 12 root 2 is the simplified answer when we multiply 4 root 3 times the square root of 6. So like a fraction, we do the multiplication and then we simplify what we get. Next one, 7 root 6 times 3 root 5. Again, multiply the numbers outside the root. 7 times 3 is 21. 6 times 5 is 30. Now we have to ask ourselves, is there two numbers that multiply to 30 where one is a perfect square? The answer, no. The numbers that multiply to 30 are 2 and 15. Neither of those are perfect squares. 3 and 10. Neither of those are perfect squares. Or 5 and 6. Neither of those are perfect squares. So 21 root 30 is as simplified as it gets. Now we're going to have a chat about rationalizing the denominator. In mathematics, sometimes we do things just for the sake of doing them. If we simplify an expression and there's a radical at the bottom, like 2 divided by the root of 3, then we want to turn the bottom, the denominator, into a rational number. In other words, not a root. We can do this by multiplying the top and bottom by the root. So we start off with 2 over root 3. We don't want the root 3 on the bottom, so we're going to multiply the bottom by root 3 to get rid of it. But to keep this an equivalent expression, we have to also multiply the top by root 3. So, on top, we're going to get 2 times root 3, which is 2 root 3. On the bottom, we get root 3 times root 3, which is the root of 9. Just 3 times 3 is 9, of course. 2 root 3 is just 2 root 3. But on the bottom, the square root of 9 is 3. So that's how we go about and simplify something so that the root is not on the bottom. And again, that's called rationalizing the denominator. Now, here's an example. 5 over the root of 2. How would we do it? Well, we'd write out 5 over root 2, and then we multiply top and bottom, both by root 2, because we're trying to get rid of the root 2 in the bottom. So, we get 5 root 2 on top. On the bottom, we get root 2 times root 2, which is just root 4. And what is the root of 4? It's 2. So there's our answer. 5 root 2 over 2. Your homework will be coming out to you on a sheet of paper. It's pages 19 and 20 from the old grade 10 textbook. You're going to do the odd numbers from 1 to 59, and you'll have a quiz tomorrow.